Okay, so for 10.1 right triangle applications, we are going to start with this formula for finding the area of any triangle, regardless if it's a right triangle or not. That is given here. Just a quick note for this, please make sure that the numbers that you're plugging in for this formula do represent numbers from a side angle side triangle. So for our picture here, we have side A, side B, and then angle theta, making our side angle side. Any other combinations of information given will not work for this specific formula. Okay, so for the first problem that we are going to take a look at, this is going to go back to some basic trig information that you should already know. But just as a reminder, we are given triangle ABC, where C is a right angle. And so now I have this 45, 45, 90 triangle. So using my information of 45, 45, 90 triangles, remember that the sides across from our 45-degree angles, we usually label those as N. And then across from our 90-degree angle, that is usually N root 2. So knowing that, if I'm looking for the lengths of BC and AB, well, right away I can say that BC should be 9 centimeters long. And then side AB should be 9 square root 2 centimeters long. And we can leave it like that for this situation. So then for part B, it's asking us to use our right triangle trigonometry to do the same thing and solve for BC and AB. Well, for that, that's going to be a little bit different. And so for here, remember, this is where we're going to use SOHCAHTOA. And so based off the 45-degree angle that we have at angle B, side AC should be my opposite side, BC is my adjacent, and AB is the hypotenuse. Okay, so then if we are setting this up and I'm going to look for side BC, well, I'm going to use the information that I'm looking for, and I'm also going to use the information that I'm given in order to help me solve using right triangle trig. When I do that, I'm going to end up setting up opposite and adjacent means I'm using tangent. So the tangent of 45 degrees is going to be the opposite 9 over the adjacent, what we're looking for is side BC. Well, we know that tangent of 45 is just 1. So we can say 1 is equal to 9 over our side BC. And then if I go through and cross multiply, I end up getting that BC is 9 centimeters, and that checks out with what we got in part A. Then for finding side AB, I'm going to do the same thing, except now I do need to change. Instead of looking for the adjacent side, I'm going to end up looking at the hypotenuse side. So that is also going to change the trig ratio that I'm going to use to sine. So sine of 45 degrees is going to be the opposite 9 over my hypotenuse, that's side AB. Well, sine of 45 degrees is the square root of 2 over 2. And so then if I go through and do some cross multiplication again, I get this. And then if I divide by the square root of 2, I get that AB is 18 over the square root of 2. And then if I rationalize it a little bit, I should get that AB is 9 square root of 2 centimeters. And again, that double checks with what we got in part A. Okay, so for problem number 2, again, we are given another right triangle. And the problem is telling me the ladder is 18 feet long, so let's go ahead and label that. And our angle of inclination, so that's going to be our angle down here, is 60 degrees. And the problem is asking me in part A, how high up the ladder reaches the wall. So let's go ahead and call that side X. Well, if I'm looking at this problem, just like number 1, there are 2 different ways that we can solve it. We can either go through and use SOHCAHTOA, or we can remember the properties of a 30, 60, 90 triangle. And so just like our 45, 45, 90 triangle, our sides of the triangle are in very nice ratios. So across from our 30-degree angle, remember that's our n side. Across from 60 should be n root 3, and across from our 90 should be 2n. And so given that we have one side, our 18 is equal to 2n, well, then we know the other 2 sides based off of the diagram. So when I'm answering A now, how high up the wall does the ladder reach? Well, that's just going to be, if n is 9, that should be 9 root 3 feet. And since this is a word problem, I'm not going to leave that in radical form because that doesn't make sense. But I am going to plug that into my calculator and get that wall will be about 15.59 feet is where my ladder is going to reach. So then part B is very easy enough. What is the distance from the base of the ladder to the base of the building? Well, that's this distance down here. And we can call that guy Y. Again, you can go through and use SOHCAHTOA, or you can notice, well, we already solved that n is 9, and this side should also then be 9 feet, and nothing more that we have to do there. We are looking for the distance from one end of the length here to the other end of the lake, and we are calling that X. And so superimposing this right triangle onto the lake, we are asked to find the distance across it. Okay, well, again, using SOHCAHTOA, the 2 sides that I'm given are my adjacent and the hypotenuse in comparison to my 40-degree angle. So what I'm going to end up setting up is the cosine of 40 degrees should be equal to that 400 meters over the length that I'm looking for. If I go through here, do some cross multiplication, and solve for X, we get that X is 400 over the cosine of 40 degrees. The problem is asking us to round to the nearest meter. So when I plug this into my calculator, I am going to round to the nearest whole number. And when I do that, I end up getting 522 meters across. For our next problem, again, we have another triangle. This entire triangle is not a right triangle, but the segment in the middle, we did make it an altitude. So that means we're going to have 2 right angles and right triangles inside of the larger triangle, excuse me. And so based off of the given information, I'm just going to go ahead and quickly label my diagram. And part A is asking us to find H to 1 decimal place. Okay, so we are used to this by now. SOHCAHTOA, I'm looking for the opposite side, and I have the hypotenuse compared to my theta. So sine of my theta, which is 39.4 degrees, is going to equal h over 43. And so when I solve for h, I can plug this into my calculator and get that h is roughly 27.3 feet. Okay, so now for part B, it's asking us to find the area of the entire triangle. And what I'm going to do in this case is I'm going to end up looking for this segment y in order to find the area, since we do need the length of the base. So now that I'm looking to find y, I'm going to use a different trig ratio, and now I'm going to use cosine of my angle. Because when I set that up, I should get that that's equal to y over the given 43 feet. And so again, when I go through and solve for y, this is a really simple calculation. You can plug straight into your calculator. And if we round to one decimal place, we get 33.2 feet. Okay, so since that is the base of the right angle, what I'm going to think of, okay, well then the base of the entire triangle should then be 66.4 feet. And so when I'm looking for the area of this triangle now, it's going to be 1/2 times the whole base of 66.4 times the height we found to be 27.3. And so that area ends up being around 906.9 feet squared. And there we have it. Okay. For a problem like number 5, this one we are going to remember our new area formula, which tells us that the area is going to be 1/2 times our two sides times the sine of our angle. The triangle that's given is side angle side, so we are all set to go. So I'm going to say that the area is 1/2 times one side is 2 and the other is 3 times the sine of 30 degrees. Okay, well, that 1/2 and 2 are just 1. So 3 times sine of 30 degrees, which is just 1/2. So this area ends up just being 3/2 inches squared. Last problem that we're going to do for today is problem number 6. Now, problem number 6 is bringing back some of our geometry skills. And so what we have here is a circle with a radius of 1 unit and an inscribed regular hexagon. And we are tasked to find the area of the shaded region of this hexagon. Okay, well, let's remember that our regular hexagons, we can split up. If I draw this, make this a little bit pronounced, we can split up that regular hexagon into 6 equilateral triangles. And so what happens here is we end up getting that each of these interior angles are 60 degrees. And we were told that our circle has a radius of 1. So I know that those two sides are both 1. I'm going to recognize, oh, I have a side angle side triangle that I can find the area of. So the area of these little triangles is going to be 1/2 times 1 times 1 times the sine of 60 degrees. And so when I simplify this, I just simply get 1/2 times square root of 3 over 2, which ends up being the square root of 3 over 4. So each one of these triangles has an area of the square root of 3 over 4. Okay, well, looking at the shaded area now, I can simply notice that I have 4 of these triangles. So my area of the shaded should be 4 times the square root of 3 over 4. And so this area simply has a And so this shaded area has an area of square root of 3 units.